Given that 3x squared plus p1 minus 2x is equal to negative 3, show that for x to be real, this inequality has to hold. Well, let's rewrite this a little bit. So we've got 3x squared plus p minus 2px plus 3 is equal to 0. So that's 3x squared minus 2px plus p plus 3 is equal to 0. Now we have real roots of that, provided that the discriminant b squared minus 4ac is greater than or equal to 0. So that's negative 2p squared, take away 4 times 3 times p plus 3 is greater than or equal to 0. So that's 4p squared, take away 12p plus 3 is greater than or equal to 0. So 4p squared minus 12p minus 36 is greater than or equal to 0, and then divide through by 4, p squared minus 3p minus 9 is greater than or equal to 0 as required. So we want to find the set of values of p for which x is real. Okay, so giving answers in exact form, that's probably a bit of a clue that we're going to use the quadratic formula, and I certainly can't see how to factorize that. So consider p squared minus 3p minus 9 is equal to 0. And then p is going to be 3 plus or minus the square root of 3 squared, which is 9, take away 4 times 1 times negative 9, all over 2. So that's 3 plus or minus, so this is going to be 36, add 9, so root 45. And that's 3 plus or minus. Now 45 is 9 times 5, so this will be 3 root 5 over 2. So we get 3 plus 3 root 5 over 2, or 3 minus 3 root 5 on 2. Now take into consideration that this is a quadratic with the coefficient of p squared being positive, and that tells me that it's this shape here. So it's going to be positive there that way and there that way, and because this is a greater than or equal to, these will both be included. So we're going to have p is less than 3 take 3 root 5 on 2, or less than or equal to, p is greater than or equal to 3 plus 3 root 5 on 2.